Okay, this video is going to go over the model of the lac operon. The lac operon is a set of gene under one switch or one control. These gene can be transcribed and translate into protein that break down the sugar lactose to galactose and glucose. Glucose then can funnel into glycolysis, Krebs cycle, and electron transport chain to make ATP for the cell to use. We're using E. coli, the operon in E. coli to illustrate how this operon work. This is called inducible operon. What that means is I can turn it on when I need to, otherwise is in the off position. So let's talk about the structures. Okay, on this operon, you have the R gene. The R gene is called constitutive gene. That means this gene is always on. It has its own control switch, but the switch is on all the time. Okay, so this is on all the time to make this, we call this the repressor protein. The repressor gene gonna make an active repressor protein because this operon is always in the off position. So from the promoter region to the end of the gene, we call that the operon, and this is the lac operon. These contain lac gene, or the gene to make protein to process the lactose sugar. Okay, so P is for the promoter. This is where the RNA polymerase is going to sit. O is the operator region. This is where the active repressor is going to sit. I use this as glucose and this is as lactose. Okay, so E. coli prefer to use glucose. So in the presence of glucose, okay, they're not gonna use lactose. So this operon is in the off position. So this is what the off position look like. The repressor is going to sit at the operator and the RNA polymerase is sitting at the promoter region, trying to move forward to transcribe the lac gene. But because there is the presence of glucose, okay, even if you have lactose, the bacteria prefer to use glucose. So this is in the off position. The repressor protein is sitting on the operator, physically blocking the RNA polymerase from moving forward. Therefore, there is no transcription and translation of the lac gene. Now, as the glucose is being used up by the bacterial cell and lactose is present, okay, the lactose is going to act or change its structures a little bit, and now we call that an allolactose. We call this the inducer. Okay, so the lactose then will bind to the repressor protein like this, so you manipulate it like that, make it click in there. Okay, once it binds to the repressor protein, you notice the repressor protein doesn't look the same anymore. Okay, so there is a conformational change, a structure change. Okay, and this will cause the repressor to fall off the operator region. And now the RNA polymerase is clear to move forward to do transcription. This turned into mRNA, and then mRNA going to undergo translation to make protein. These protein then will use this lactose sugar, break this into galactose and glucose, build up more glucose for the cell to use. So over time, more and more of the lactose is being used, including this one. So this one is being used to fall off of the repressor. So now the repressor protein become active and it will have, there's a change in conformation, a change back in conformation, and it will bind to the operator again and blocking the RNA polymerase from moving forward. Why? Because now we have glucose. Glucose came from the breakdown of lactose into galactose and glucose. So now glucose level is built up in the cell. So the cell will switch back into using glucose. And so therefore, the operon is in the off position by the allolactose fall off of the repressor protein. The repressor protein is active. It's going to bind to the operator and blocking the RNA polymerase from moving forward. So we go back to the off position. So when the allolactose is able to bind to the repressor protein in the absence of glucose, and this fall off and allow the RNA polymerase to move forward, we call this inducible. We just turn this gene on. Okay. When the lactose is being all used up, the repressor will bind to the reposition, bind to the operator, and now the RNA polymerase cannot move forward. So now is in the off position, which is original. I hope you make use of this model. I'm leaving this model at the Success Center at Chino. I hope you make use of the video and this model and manipulate the model and hopefully help you understand better the mechanism of the lac operon and how it works. Enjoy, have fun.